Hi all. Today we'll discuss about question number 21 from GATE 2020 first paper. So here you are given a balanced rigid disk mounted on a rigid rotor. So this is the system, and it is given that all these 4 point masses, that is A, B, C, D, having similar properties, that is weight and its distance from the center of this system. So it's also given that the rotor is rotating at 10 radian per second. So now the question is, if one of the masses gets detached, then the magnitude of the resultant unbalanced force on the rotor is. Okay, so this is a question regarding centrifugal forces. So you can check out about this topic in engineering mechanics module 9 by Professor Manoj from IIT Kanpur. So let's check out some of the useful information. So we know that if a body is moving in a circular motion like this about a point, so it will experience centrifugal forces and centripetal force. So the formula for centrifugal force is given by F is equal to mv square by r, or it can be simplified to F is equal to m omega square by r. So let's see how to use this information in our present given problem. So now let's see how the problem works out. So if this is my point, center point, so you're having a mass here, 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 and here. Assume it is at equal distance. So what is going to happen is, along this line it's going to, let's say uh, it's going to experience some centrifugal force like we saw earlier. So along the center line, okay, so you can see, so now all these angles are 90 and all these distances are your radius. Okay, so what they are essentially saying is, what happens if, let's say, this point mass is taken out, and then what is the net resultant force in this particular system. So if you take force vector, so before that let's see, let's consider uh, this coordinate system I cap and j cap. Okay, so now your force vector you can write as, let's say first this one. So you're having in long I direction, so you're going to write fc magnitude into its vector I cap plus then this, so your fc into negative j. So let's just write it in this way, plus now we are going to do for this particular thing, so that is again, so into negative I. So these are the direction. So plus you would have got one more force, but that is right now 0 because we have cancelled this thing. Okay, so when you simplify, you can see that these two are actually in opposite direction, so these two get cancelled. So finally what you're going to get is, your force is minus fc into j cap. So your magnitude of the resultant force is this fc. Now we know that this fc is actually m omega square r. So let's solve this. So your final answer will see, so m into, so m is 10 grams into omega square, that is 10 radian per second square into your radius 100 mm. So this, when you actually convert it into SI units, you're going to get this into, yeah, this will remain same, into 100 into 10 raised to minus 3 meter. So when you actually solve this, your final force magnitude you're going to get is zero point 0.1 Newton. So this is your final answer. So let me just talk about a little bit more on this. So as you can see, your system was like this. You had four masses, right? And you already knew that this will be the force directions. Okay, yeah. So if you take out this force, you can see that these two are actually equal and opposite. So you can automatically take out, and finally you could have easily simplified it into FC. You didn't have to go with IJK sort of a solution. But why did I show you that is because when you have a bit more complex systems, you will need something like this. So it's good to know the conventional way also. uh, okay, so I guess everybody understood the problem. So thank you.